Strong, the GDSC lead for at UE St. Augustine. Thank you for joining us. Today we have our four guest speakers who will be joining us. Mr. Juerg van Kaenel, Director of the Center for
It's pronounced CRE, Center for Industrial AI Research and Innovation.
Yes, my apologies. He's the Director of Center for Industrial AI Research and Innovation at RMIT University. Our next guest would be Ms. Rita Arrigo, Deputy Director of Center of Innovation, Center for Industrial AI Research and Innovation at RMIT University. And our two local guests, which would be Professor Patrick Hosein, Professor in Computer Science at UE, and Mr. Inzamam Rahaman, Senior Data Scientist at the Guardian Group. Right. First up on our agenda, we would have I would hand over now to Mr. Mendez, who would be taking you through the following activities.
Hi, everyone. I believe we first have, as the agenda that Jeremiah showed, we have a presentation by Professor Juerg. So I guess we can go ahead and get right into it. Professor Juerg, can you confirm if you have the ability to share your screen?
Uh-oh.
It should be at the bottom here.
Yeah, except it says something about system. Allow the below applications. Chrome. Uh-oh. It seems I need to restart Chrome.
Okay. So he'll probably join us in a bit. So Professor Juerg's presentation is entitled AI from Past to Future. So judging by its title, I assume it's somewhat of an overview, and I think it's good to get out context for the audience that we have here. Maybe just to give some more context, we are I believe, Jeremiah, this is like the second event for GDSC, or will you count this as the first? Oh, he's back.
Okay, so let's see if it works now.
Okay.
Share my screen. Share. So, can you see my screen now?
Yep.
Yes.
Great. So thank you for this opportunity. When we prepared for this, it was asked if I could give a short overview over the history of AI, and I gladly accepted that, and then I got kind of sucked in to look at this. I knew a lot of it, but as I researched it, it is amazing how far back this actually goes. We're currently living in a time where AI is very much hyped up, and so we easily forget how far we have come. The dream of intelligent machines is at least as old as recorded history. The seeds of modern AI really were planted by classical philosophers who attempted to describe the process of human thinking as the mechanical manipulation of symbols. And if we think of the word algorithm, that actually comes from the person who developed algebra around 820, Al-Khwarizmi. And if you kind of pronounce that very fast, you can see how the word algorithm was derived from his name. So this goes back a very long time. And the idea of intelligent machines, or at least machines to begin with, the very first robot we have any kind of historical record about is the steam-powered pigeon from Archytas, 400 BC around. And supposedly it flew about 200 meters. So quite a feat, very, very long time ago. Now, the first big human kind of looking robots described in history was the mythical Greek robot protecting Crete, Talos. And it was later defeated by Jason and the Argonauts. It had an Achilles heel. Its system had a little plug which sealed in the acre of life at its heel. And so just they pulled the plug, and that was the end of that robot. But as you can see, we've been dreaming of such machines for a very, very long time. Now, there have also been fake machines. Very famous, the Mechanical Turk, the Mazel's chess player. It toured Europe and America, but actually a little person was inside it to actually play chess. So that was all fake. And myth around all kinds of machines are at least as old as that as well. Golems going all the way back to 800 BC or more. And then the homunculi, mostly in the European history, and Frankenstein, all kinds of myth around these. So if we start to look at this, and I could have added a lot more of examples. There are many, many, many more in this space. But let's start to look a bit closer in at the last and the current century. Now, even before we had robots as we know them today, there was actually a play in 1920 which showed off robots, and they were essentially slaves, and they revolted against slavery in that part. So that whole topic was in the history and in literature way before we actually could really build any such machines. And as we get closer to current time, we don't call them myth anymore, we call them hype. And so in the 60s, when AI kind of started, HAL was predicted by 2001 we would have a really intelligent machine. In also the 60s, we had the cybernauts, assassin robots, and then obviously Terminator. And you can add many, many more to this. In fact, in history, there are many more things going wrong in AI than there are robots, which are good for humans. And real robots, as we know them today, obviously the vast majority are industrial robots. We don't see much of them. Maybe you have a Roomba at home, which helps you clean the house, but everybody is thinking of human-looking robots, although some of the ones you've seen recently coming out of Boston Dynamics, like Spot the dog, are amazing progress we've made in these spaces. So we look a bit at the more recent history. Early things were cybernetics in the late 40s, early 50s. And then Turing invented his notion thinking about intelligent machines and developed the Turing test. If a machine could behave that you couldn't distinguish whether it was a human or a machine answering the question. So that's the Turing test. And the Turing test by today actually has been fulfilled in many, many cases, definitely in specific fields, but also in general, there have been machines which most people can no longer distinguish whether it's a machine answering or a human answering. The real start of AI was 1956. There was a big workshop in Dartmouth, and they desperately did not want to call it cybernetics. And so Minsky invented the term artificial intelligence. And that has stuck ever since then. And in the early days, they were really still in that philosophical notion from way past when, from the mathematical side. Can we, through mathematical manipulation of symbols, get to artificial intelligence? So symbolic AI and reasoning were kind of the thrust of the research, coupled with natural language processing, because obviously all of this had to work to interact with humans. As that was going on, the hype around AI started to increase more and more. And in 1970, Marvin Minsky predicted that within 3 to 8 years, we will have a machine with the general intelligence of an average human being, AKA something with an IQ of 100. Now, we all know that didn't really happen. And then later, by somewhere around 2014, 15, I don't remember the exact date, Marvin Minsky changed his prediction to say it'll be 2029 that we will have such a machine. Unfortunately, he obviously never has heard about how to do predictions. I call it the Heisenberg's uncertainty principle equivalent for forecasting. Never predict both the what and the when, because you're certainly going to get one of them wrong. And so prediction is a really, really difficult thing. Will we ever have human intelligent level machines? I don't know. It won't be in the near future. I'm fairly certain of that. Will we have very good machines? I think so. So big disappointment, huge crash, and what's now called the first AI winter happened, as a lot of what I call marketing happened, a lot of hype, a lot of overpromising and under-delivering. The systems really didn't perform. And then the focus switched from symbolic AI to expert systems. Hype built up again, and unfortunately turned out to be a lot harder than we thought. One of the things we only learned in more recent years is that things which are hard for humans are easy for computers. We thought doing things like mathematical proofs would be really hard, but actually turns out that's not that hard. Or in cybersecurity, we now have successfully trained people to invent complex passwords which people cannot remember, but computers can easily guess. And so things which are hard for computers are possibly easy for humans. Think about things like computer vision. We still need thousands of images to train a computer, whereas you can show an image to a child and it can easily recognize it. So after this, we entered the second winter, and Wikipedia claims that was from 1987 to 2003. I personally experienced it more like lasting until 2011. Now, during that time, AI kind of fractured into many fields. People started to really focus on technical issues one at a time. And we started to add not just math, but also things from decision theory, from economy, and started to think through what is actually meant by human intelligence. And so intelligent agents got built, speech recognition got really started there. And a lot of focus was also on game systems, because it was believed that if you could understand how to build game playing systems, that would help a lot with advancing AI. Deep Blue beating the chess champion in 1997 was the first really big of those things. And then everything switched to big data, and the hype curve started again with Jeopardy in 2011, when computer Watson beat the then reigning Jeopardy champions, the person who won the most money and the person who won the most matches in that. It's a really, really big deal, was big televised. It's actually an interesting backstory there. I was personally in the Yorktown Research Center of IBM at the time, and obviously was following that project very closely. But some of the interesting things, IBM was doing a lot of research around these question answering systems. And those of you in academia who may be old enough to remember those times, KDD was running competitions every year, and IBM was winning those year after year. So they got asked to no longer participate, but could they actually run them? And then somebody higher up in the executive ranks of IBM said, who's ever heard of KDD? If we really want to show that we can do really good AI, then we have to beat Jeopardy. So that's how that's set up. It's a whole long story of itself. But it set the world on fire. And when you couldn't actually tell that you were working in AI before that, after that, it took off. All the universities went back into AI with a vengeance. And this whole thing took off, especially with deep learning. Somewhere around 2013, 2014, big shift in the image clef. To win the image clef, you had to be about 40, 50% right. Pre-deep learning. With deep learning, in 2013, the accuracy to win jumped to 66%. And only 2-3 years later, accuracy in image recognition actually started surpassing human accuracy. Just to give you an idea, answering the question from a picture of the skin of a person with a lesion, whether this is melanoma or not, a human radiologist has an accuracy of about 85%, meaning 15 out of 100 patients they get wrong. The accuracy of the computer's recognition of this was around 96, 97%, so much, much higher. However, it could only answer the question, is this melanoma or not? We still can't answer a general question like, what do you see in this picture? So that's still way, way off. And you have to think about the human brain has about 100 billion neurons. The network used to beat the human accuracy in melanoma recognition only used about 5 million neurons to do that. So huge difference, and we're still far away from human capacity in these things. Will we ever reach it? I'm sure we'll get closer to that at some point. And then more recently, AlphaGo beat the human champion when everybody still believed that Go was a game where a computer has no chance. And general AI is being discussed again. I think we're still very far away, but we will make a lot of progress. And so the hype right now is, again, at a very high level. And where will it end? Where will we go? Will we have another winter? or will we actually reach escape velocity this time, and we won't have another winter in this space? I think we're going to see a separation of what some people call narrow or small AI, which will make tremendous leaps and progresses forward, and general AI, which I think will still continue to overpromise and underdeliver. So if you are currently studying AI, think back. You may not have realized the dream is very old. You can go all the way back in recorded history. There is lots of hype, and if it's old hype, then we call it a myth. And there have been lots of booms and busts, but tremendous, tremendous progress in this narrow or specific AI over the last 50 years. And so will we reach escape velocity? Will we see another winter? I don't know. But I think we're going to make tremendous progress, especially in the narrow AI fields. We will build very, very important tools for humanity in the next decade. And you got to be in it to win it. So you're at the right place at the right time. I think we're living in very exciting times. And I want to end this with my modified version of Clarke's third law. Any sufficiently advanced technology appears as magic. Any sufficiently well-trained deep learning model will appear as if it's intelligent, which will be sufficient to build very, very powerful tools. With that, back to the organizers.
Great, thank you very much, Professor Juerg. That was quite educational. Next up, we have the panel talk by our guest speakers, which would be Professor Juerg, Mr. Inzamam, and Professor Patrick Hosein. Oh. Conduct this session, we have Michaela Noel and our MCs for the panelists.
Hi.
Hello, good night, everyone.
Hi.
Hi, good night.
So, how is everyone tonight? We just want to start off by thanking all our panelists for coming out. If each panelist would like to tell the audience a bit about themselves and their research areas, that would be lovely.
What order do you want?
Anyone can start.
You can start with Professor Juerg, and then Mr. Rahaman, you can go after. Then Mr. Hosein. Yeah.
Thank you. I'll probably should have said a bit something about me at the beginning, but I studied math at ETH in Zurich. At the time, computer science didn't exist. There was a big fight to convert all the math students to computer science at the time, the new study they started. And I decided to finish math because they couldn't decide whether soldering was part of computer science or not. And I'm happy I finished my computer master's. And by that time, they've sorted out the soldering question. And I did a computer science PhD at the time. At the same time, I was actually working at the Zurich Research Lab as a pre-doc. And when I finished my PhD, I got to the US in the main lab of IBM Research in New York. and spent 20 years there. And then they sent me to Australia to build a new research lab here. And then most recently, I semi-retired kind of from IBM, and I started a new job with RMIT to head up their new AI center.
Okay, so I guess on to me then. So good evening, everyone. So I did my BSc in computer science at the University of West Indies at the Augusta campus. After that, I was afforded the opportunity to be an intern at the NASA Ames Research Center in Mountain View, California, under the auspices of the NASA I-Squared Fellowship Program, which is a initiative by NASA to link with the scientific bodies in different developing countries to help forge collaboration and exchange of ideas and skills. Afterwards, I took a gap year and actually spent it as a research assistant for Professor Hosein. After that, I started my MPhil in computer science. Initially, I was going to work in programming language theory, which was throughout most of my undergrad, you know, which was the area that actually most interests me. But we ended up working on some interesting problems at the intersection of optimization, machine learning, and graph theory. And so I decided to do my research in that area. So I was recently upgraded from an MPhil to a PhD, PhD candidacy from December of last year. And my research areas would be applying ideas and tools and techniques from machine learning, data science, and algorithmic game theory to social networks. Currently, I'm also working as a senior data scientist at the Guardian Group.
Okay, so yeah, I guess I'll go next. So I assume this is mostly students from DCET, right? Is that true? Okay, yeah. So some of you may know me. I don't really teach many undergrad courses. So my background, I went to MIT. Spent quite a bit of time there. Did all my degrees. Ended up with a PhD in electrical engineering and computer science. Then briefly worked for Bell Labs on telecoms. Various types of controls. In those days, the emphasis was on switching systems and optimizing switches and various components of the telephone network. Then I came back to Trinidad, joined the Department of Electrical Engineering, and was there for about 3 years, working mostly on data communications, and actually doing things like packet radio networking, etc., with the Amateur Radio Society in Trinidad, as well as getting involved with the internet, because there was no internet at that time, and I wanted to get access to the internet. And so that's how I got involved in, starting up internet connectivity for the university over a dial-up connection. So, in the really early days, the way the university actually connected to the internet was on evenings. I would use our fax line, and they only allowed me to do it after business hours. So I would dial into Puerto Rico, which had internet access, and interconnect with the UE campus network. So we had a campus network, but no internet access. And students in the the computing center would then access the internet through that 9.6 kilobit per second connection. So of course it was slow, but you could get emails and simple things across. Actually, what we did is we had a separate system for emails using UUCP. Anyway, going on. Then I went back to the US, worked at Bell Labs again, and then AT&T Labs. Then decided to switch to wireless communication. So I moved over to Ericsson in San Diego. Did research in 2G, 3G, etc. Switched to Huawei. Again, working on wireless networks and mostly in algorithm development, scheduling, etc. Then after Huawei, I decided to, I briefly went back to AT&T, but then I decided to return to Trinidad, and but I decided to join the computer science department because I wanted to do something a little bit different to what I did before. So I've been back about 10 years. My focus is on a combination of things. I still try to do some communication system stuff with some students in in electrical, but my main focus is on data science and running the MSc in data science program, and we're now proposing a PhD in data science. So my focus is really to get students interested in research and having them do research, publish, and get to the level where we could contribute at a higher level than just development, just all of sorry, I shouldn't say that because this is a developers group, right? But I think you understand what I mean by that. It's really pursuing algorithms and data science beyond what we've been doing in the past. So any of you interested in the work we are doing, just go to our site, lab.tt, lab.tt, and you will see some of the stuff we do. So we do more applied data science because we can't compete with research being done at Google, Microsoft. We don't have the resources, we don't have the data, we don't have the computing power, and so we focus on problems that really affect us within Trinidad or regionally. We've done work for Barbados, etc. So it's typically a different type of problem, being less data. It's not a big data problem, and so you need to use different types of approaches. You just can't throw the data at a neural network and get results. So it requires a lot more thought. But we've been doing some interesting work and publishing. So yeah, so that is my background. Thanks.
All right, thank you guys so much for introducing yourselves. Now we're going to move on to the open panel where me and Michaela will be asking the questions.
Yeah. Okay, so the very first question we have for you guys is, how do you see the evolution of the role of AI in society?
So either we can get an answer from all three of you, or anybody who wants to speak can, take the question.
I suggest we go in the same order. We introduce
Same
ourselves.
order? All right, no problem.
Yeah. So I think we will see humongous changes behind the scenes. Things like robotic production, stuff which can be done, and things which sneaks in like Roomba robots, which aren't very intelligent, but intelligent enough to do their job. That will be the biggest change, but society will be more interested and threatened by the humanoid-looking robots, as well as things which directly come from influencing consumer behavior, things like decisions about whether you get a home loan or not, things about self-driving cars, which are huge discussions going on. And all of those are ethical, philosophical questions in many cases. And they all start around the form of, if you're a self-driving car and there's an accident about to happen, and you can either kill the old Nobel Prize winner or the young woman with the child, which one would you? And interestingly enough, there is no real right or wrong answer. It's a societal question. And there's a big study which showed that different societies in the world, and I forgot which is which. I think the southern societies decide for the higher status, the Eastern societies for the women with child, and the Western societies go into analysis paralysis. And I call that, we kill them all because we can't decide. So going to be very, very difficult questions in that space. But the big changes are the ones which aren't really seen behind the behind the scenes, and that will. There's a lot of hype. There's a lot of questions about losing jobs. We will lose a lot of jobs, but it's easier to predict which jobs AI can replace. It is much harder to predict which new jobs will be coming. And through every technological revolutions, we had more jobs afterwards than we had before. So I'm not as worried about everybody losing their job as some of the hype is going on there. Just haven't figured out yet what all the new jobs are.
Okay, so for the I actually pretty much really agree with the previous statements. A lot of the changes that would occur to society would be ones that are more or less inconspicuous, things that you might not necessarily notice. I think a lot of the role that AI would have in the evolution of society would be through its use in decision support systems. Personally, jumping off of the issues of ethics and fairness in these AI systems, and as somebody who actually works on as a day job, actually doing developing decision support systems, I'm not exactly fond of the idea of these systems making judgments completely on their own without any human intervention or input. Um, if these actions, if an AI system is going to say that something should be done, it should be a human that has to evaluate that and take responsibility for the ethical consequences of some of those actions. So I think I see a role for it there. There are a lot of problems, in terms of you have travesties such as what happened with the Compass case, where racial bias was encoded in systems to predict recidivism. You had, I believe, a similar case with Apple, with the Apple Card, I believe, recently, where um, couples where their financial background would be the same, the woman's credit allowance would be lower, or she'd be actually denied the card. So I think we need to fix those issues. Those are very important issues, because we already have these sort of biases as problems with this society. We don't want to actually automate them. Automation has a tendency to make things more efficient, and that includes both the good and the bad. So I think we need to spend some time trying to find ways to emphasize those good and positive aspects, preclude those negative aspects, and focus heavily on trying to build decision support systems in that vein. I think as well, a bit of an aside, I think this is sort of tangential to AI, but I also think there's a lot of room in the space of human-computer interaction and how it interacts with AI, because if any of you have read work like Daniel Kahneman's Thinking Fast, Thinking Slow, as well as similar work in behavioral economics, we want to design systems that okay, this AI system is presenting a particular decision. How do we avoid things like anchoring bias? How do we design these interfaces to play well with human psychology, such that this interaction between humans and machines actually yields the most positive social benefit? So I think that's where the evolution of it should ideally go. Oh, excuse, Prof, I think you're muted.
About going last is you don't have to say much, right? The previous people would say. So yeah, so I agree with what has been said so far. My concern, of course, is the fact that a lot of these technologies are being, there's a monopoly by the big tech companies. they have the data, they have control, they have the computing power, and because they can now reach globally, they have control over the global population, especially smaller countries, developing countries, and there's a risk of us losing our identity, our culture, because we, just like you have McDonald's coming into to all these developing countries, you don't want to have the influence of whatever these how should I say, the big tech companies making the decisions for us. So that's where I think it's important that we, when I say we, developing countries, have some input into what tools are being used, what techniques are being used for our communities, and I need to, the other issue I think we need to focus a lot on is using these tools for social impact, not only for making money through Facebook, Google, etc., but how do we use it to improve society, to reduce poverty, to increase food security, etc. So that's where, so yes, the developed countries will go in one direction, but the developing countries, the smaller countries, also need to be on that bandwagon as well. Yeah.
Yeah, and if I may add to that, there's actually a lot going on in thrusts about using AI for good. I'm always a bit worried about, there's also bad players out there, and they will use AI for their own goals no matter what. And so the big companies just looking at profits is kind of in the gray zone, not great, not good, part of this. And then to Inzamam's point about HCI, I've started to see the emergence of talk of what they call the silver collar workforce, being robots. And so that whole HCI and how do we interact with these decision systems coming to the point where they're not necessarily automated, but more like your friends and partners in helping you finding the right facts and then leaving at least some of the decisions in human hands. I think it's going to be a very, very difficult thing for us to struggle with, both technologically and societally, because also different societies have different values.
I think there's a lot of value as well in things like at KDD every year for the past couple of years they've run this workshop on human in loop systems. So I guess over time those work in that direction just become incredibly and increasingly more important. I guess on topic of the big players, I think I think it is more educational, but I do think at some point some basic understanding of AI be required in fields such as law, because as these systems start to move into deployment, with there being ethical implications, there should also be legal implications. Algorithmic auditing is a field that's developing, right now, and I think needs to be in the legal vocabulary of a lot of countries. I think.
Yeah, and that's another good example, which is hard for humans and easy for computers. Law, in many cases, is just a play of words, and that's actually easy for computers to understand and get in. But what the law means versus what it says, that's the really hard part. When we tried to build a system which could do good summaries of texts, we actually started first building a system which could write Shakespearean sonnets. And, all the humans kind of think, whoa, all these rules, it's really hard to write these. But it turned out it's much easier for computers to write sonnets than to write good summaries, which are free form, because computers are really good at all that rule stuff and we humans aren't. So you're absolutely right there.
thank you guys for your answers. The next question that we have is, what kinds of problems or issues students interested in AI should be on the lookout for?
Not sure that they should look at, I mean, there's kind of the academic field of AI, and you could pick an academic problem, but in the vein of what we just discussed about society, if you think about what really bugs you in life, what would make your life and your friends' lives and your family's life easier? What are the things we should be solving? And then use AI as a tool to solve it, not look at, you know, AI problems as in theoretical problems. But that's my particular bias. I do like real world problems. And so I think it's my advice to students was, look at real problems. And if nobody is solving them, that might be your opportunity to build a startup.
My advice would probably be similar as well. I think a lot of the interesting and fruitful, most impactful work in AI, especially given the theoretical underpinnings we currently have. I mean, of course, there's a lot of work still to be done in theory. If you're the sort of person who really likes like real analysis and like mathematical statistics and the like, there's a lot of really interesting work there. But I think a lot of the really interesting problems in AI act as the interface between AI and different fields. So I guess again, things like looking as well as the intersection between AI and these different fields, of course. I'm sure there could be work, like if you're interested, probably like a research degree after your bachelor's, maybe even looking at like doing computational law with the AI. Of course, there's work in bioinformatics. Bioinformatics right now at one point was pretty much dominated by a lot of string processing, and now it's like you go read SIG bio proceedings, and it's pretty much neural networks everywhere. So I think there's a lot of interesting work there, and actually taking AI and applying it to medical problems. Of course, solving these general problems related to things like fairness and accountability and interpretability, of course, are really important. And of course, and as well in terms of those interfaces. I mean, in terms of trying to build, interfaces that try to steer us away from those infirmities of the human mind, you don't find, I think, too much work being done there. But I think that's an area that we should probably be looking at, especially with these AI systems, because if you want to have these human loop systems, the idea is, humans and these systems working together, but you can design it. But if it's not designed well, you can just have, you just see the output of the system and you just go with it blindly, right? So how do you build those systems? So I think there's a lot of work with the intersection between AI and those fields. I guess a bit of an aside as well, to that point, what I'd kind of recommend to students, particularly within our Caribbean context, there's this serious issue of intellectual siloing within the Caribbean in particular, partially because of how we structure pre-tertiary education. I think it's quite hurtful to students' intellectual development, and I would encourage students to read very broadly. If you even say you want to work like outside, say as a data scientist in industry, like something I think is really beneficial is to understand some economics. So to actually be able to use these things out there in the real world. So I mean, it's a bit of an aside. It's probably that little bit there is probably not necessarily answer the question directly, but it's just a bit of an aside. I'd recommend try to read broadly as well, to try to get a sense as to what problems you might actually want to try to solve.
Okay, yeah, and to add to Inzamam's point, there's no need to follow the traditional approach of I have to take course A, then course B, then course C, then I could do whatever. If you're interested in a topic, go learn about it. Go online. There are lots of resources online. Learn about it, and you could do research even on that particular topic. I have had undergrad students come to me and say they want to do research, and I tell them what they need to learn. They go ahead and learn it, and we come up with a problem to work on, and they solve it and they publish. So don't think that research is this thing that you have to wait, 5-6 years before you can actually start doing it. Of course, pay attention to your grades, right? But explore, as Inzamam said, read, explore. The other thing is what problems to work on. You don't need to work on some of these highly theoretical stuff at this point in time. As Professor Juerg said, think about the issues that affect you right now in your life. So when students come to me asking for a topic to work on for their thesis, I try to match their expertise, what they know, with their interests, and see if they could find some problem that they're interested in that they could solve. And sometimes it's a wide range of backgrounds that I deal with. But if you're not really invested in the problem or interested in it, you won't really spend the time you need to spend on it to come up with a good solution. So always keep in mind, everyday problems that could solve. You don't need to get some highly theoretical problem to work on. And that's what we try to do. We try to work on problems in industry. We work together with industry through these internships. In fact, Inzamam was one of these interns at his present job, and they hired him because he was exceptional. But yeah, you work on real problems, but it also gives you the ability to publish, because we've done work with local companies and extended the concept to a more general framework, and publish it as a theoretical result, an optimization problem. So don't be afraid to dabble. That's what I will say. Thanks.
Yeah, and to your point about publishing, if you actually work in a internship or in a real world problem with a company, you can publish both the theoretical framework and then the real test results of how well it worked in the world. And I personally like those papers the best, where you build a new framework and it says, in theory, you should be able to do blah. And here in this practical example, we were able to get to 90% of theoretical possibility. And that's a very, very powerful paper.
Yeah.
Thank you for those informative answers. A follow-up question to that is, what kinds of AI-related jobs should students look to get into at the entry level?
That's a really hard question, because some of these will be new jobs which we really don't know about. The best advice right now is, as a student, is try to get internships. That will get you at least some understanding of what's going on in industry and in the real world. I'm sure there will be new entry-level positions appearing. I just don't really have a good idea what they will be. Sorry, not the answer you wished for.
It really is a sort of difficult question to answer, but I suppose at least within our context, data science as a field has been ramping up. Now data science is not entirely just AI and ML. There are other aspects of data science. In fact, I know Jeff Allman. I believe Jeff Allman is quite vociferous that he actually believes data science is the outgrowth of the database tradition more than it is of the machine learning tradition. But I think if you're interested in AI and machine learning, I think data science is a really nice place to apply those techniques and those ideas in industry. So that is of course one avenue, one area you can look into. And there are data science is starting to become slowly recognized as a profession to help take the Caribbean forward. So I would suggest looking into those sort of entry level data science positions.
Yeah, in terms of entry level, one complaint you sometimes get from companies about recent graduates is they can't apply their knowledge to real world problems. All right, so they go in there and they know the solutions, they know the techniques, but they only know how to apply them to well-defined problems, and that mismatch is what causes issues for some new graduates. So again, which is why I mean when I in my courses I try to provide real world examples and have them work on things from scratch as opposed to giving them a well-defined problem. So again, if you could just by reading or by practicing or whatever it takes to be able to bridge that gap and be able to look at and again, this comes back to looking at your everyday life. Some of the problems that we've worked on is based on my experience. For instance, things like we've done work on a framework for comparing ISPs because I wanted to figure out what's the best way to compare ISPs. So just see problems you face day by every day and see how you could solve it.
If I may add, Inzamam's idea of the data scientist, I think, is a very good one. On one hand, I see that field a bit in a crisis. When data science started, it was defined as person who knows how to analyze data and to ask the right business questions. Every university churned out data scientists which knew all the analytics and had no business acumen to ask the right questions. And so getting an entry-level position and then being widely read. So when you see things like your data says that your company has a profit which is bigger than the GDP of your country, and it's a small company, you're probably wrong. So being widely read, understanding connections and positions which allow you to get that experience, entry-level positions which allow you to get that experience and get your broad understanding. And as Professor Hosein said, was the real world problems, kind of still the biggest part of data science questions is you spend 3/4 of your time cleaning the data and figuring out what the questions are and whether they're the right questions. My favorite example there is a famous graph of damage by a fire and number of firefighters involved. And when you plot that nicely, you see that the more firefighters you send, the bigger the damage of the fire. So the conclusion obviously should be that you send less firefighters, when clearly it's a correlation, but it's not the causation in that case, right? And so getting an entry-level data science job, which lets you start to really understand that difference and see lots of examples and being able to apply common sense knowledge to that, so that you're asking the right questions and you come up with the right questions to ask. Once you know the right questions to ask, finding the solution in the data is often a lot easier than just looking at the data and says, oh, there's a trend, but what does it mean?
One thing to add to that is be prepared to do a lot of work in learning about the specific domain. The nice thing about data science, it applies to multiple industries: insurance, banking, you name it, telecoms, power. When you get in there, you will have to also learn the domain specific terms, etc. So be prepared to have to do that. It's not like you're going into a job where you know the background or the domain of the job itself, and that's one of the things that you need to ramp up quite rapidly. in order to start contributing to the company?
Yeah, in that sense, it's an interesting question I got asked a lot is when you enter industry, where did I spend my education dollars, right? The university gives you a really good training on the technical side. I spent all my education dollars when I was running the IBM Research Lab in presentation skills, in business acumen, and in leadership. No technical, because all the technical stuff you bring from university, they taught you all that stuff, they taught you how to learn. Almost everybody can keep that up, but all these other things which then make you a well-rounded person and so as much as you can get now during studies in those fields would be really good.
Oh, and also people skills and communication skills. Be able to work with other people, showing your strength, but not showing it in such a way that you offend them in any way.
Yeah.
Thank you guys for the advice. It was very helpful. Moving on to the next question. What is the possibility of achieving a machine capable of actual thought? And should this be the goal of AI research?
I think at some point we probably by some definition will reach such a machine, but it won't be any time soon. I think that will be useful. So we're probably another, I know I shouldn't say any years, but I think we're probably another 50 years away from that.
Yeah, I would agree. I think really it depends on one's definition of what it means to think. If you ever reach a thinking machine, even our most sophisticated methods, let's say like deep learning, we know it's not exactly a perfect correspondence to what actually goes on in our brains. There was actually in 2019, towards the end of 2019, there was an interesting paper that so there's this problem called the XOR, in trying to learn the XOR function. For those of you who would have done computer architecture, you remember the XOR exclusive OR. And so training an artificial neuron, you can't take a single artificial neuron and learn to solve to actually train it to actually be able to perform the XOR operation. But it turns out you can, in fact, train a single human neuron to actually do that. So we know that our artificial neurons are a far cry away from natural neurons. And I believe in the September of this year, there was actually a paper published in, I believe it's Elsevier's journal Neuron, that actually saw that you need about 5 to 8 layers in a deep neural network to replicate some aspects of a single cortical neuron. So, I mean, we are very, very far off in terms of, what, more sophisticated methods can actually achieve. And then there's even theoretical questions about if it can even be achieved. Some of you might have heard about Searle's Chinese room argument. It's a shame if you've never been in CSL2, because at the back of CSL2, there's actually, this big board actually talking about Searle's Chinese room problem. And just to summarize it, the scenario, imagine you have this room that has this guy who, when he's given cards with Chinese symbols on them, he knows how to then take some cards he has in the room and just shove it through an output slot to give sensible responses. So you have these native Chinese speakers, well, I guess that's Mandarin speakers. They come, they push their input cards representing sentences in, they get sentences out. And to them, they observe sensible output. So to them, they might think that the room understands Chinese, but we know that it doesn't in any meaningful way actually understands Chinese. It just follows these rote instructions. And that sort of raises an interesting question. If all of our systems are just basically symbol manipulation, these sort of rote symbol manipulation, right? This is what essentially computers do. Can they ever really be intelligent, right? Because it can't, because we ascribe to intelligence the ability to understand and to be able to attach meaning to some idea, right? Can computers ever really do that? And of course, that's a really interesting problem that I don't think we have in either direction a compelling answer to. It really is a difficult question to answer. And of course, in terms of whether or not we should try that, I mean, I would argue to some degree no. I like to joke it's that the field is called artificial intelligence, not artificial stupidity, and we have to be a bit careful about which aspects of human thinking we actually choose to automate and replicate as well. So, and I personally, I think it's more of a pie in the sky sort of ideal. I think it's probably a bit better to focus on solving these real problems rather than necessarily spending. I mean, of course, there's merit and value in it, but I think it's better to distribute our effort into solving these real problems rather than try to chasing this pie in the sky ideal.
Yeah, I mean, I do think generally AI is a long ways off. And remember, machine is only spitting out what you put in, right? And even if you could feed that machine everything that a human receives in terms of sensors, sight, etc. The question is there something beyond just sensory input that a human has that you cannot include in a machine? And so I believe I believe that's the case. And if that's the case, yeah, we will never be able to replicate human thought.
I suppose in that point as well, evolution has baked into our brains at birth certain, essentially, you can think of it as like procedures, right? I mean, human beings take a long time to walk, but if you imagine, like say, other living things, they tend to be able to walk rather early. So and there's certain behaviors that are borderline innate, for lack of a better way of putting it, that has been sort of encoded us into by the evolutionary process. And I think, like, if we want to have anything like general AI, we'd have to find some way to sort of encode that as well in some way. I as well, like, I'm sort of thinking of Chomsky's notion of a universal grammar, that is this idea of some sort of underlying grammar that underscores all grammars of all languages, and some of the thought processes goes behind that it's really just the encoding of this universal grammar within human mind that kind of allows us to be able to pick up and develop language the way we do. So in terms of replicating it, there's still a lot we don't know about our own brains, and about and a lot of things are vague, very vague, right? Ask someone to define intelligence, ask 10 people to define intelligence, you might get 2 out of the 10 answers somewhat agreeing and corresponding with one another. So I mean, that itself, that's philosophical and semantic philosophical and semantic issues as well would actually frustrate attempts at developing general AI, because we don't know what general AI would actually really mean.
Yes, those are really good answers and a really nice insight into the future of AI. The other question we have to ask is, what is one memorable project or breakthrough in AI that you have worked on recently?
I think for me, it really was that breakthrough when we managed to get better at image recognition than a human on a single task. Yet we still can't ask a computer whether, what's in that scene, and understanding more of how the human brain works will be crucial, because we still can't explain why a 2-year-old, you can show one picture of an elephant and they can recognize elephants. And we have to use thousands of pictures, like in this melanoma case, to train it on melanoma. And yeah, we can do better than that on humans. But if you just show them a picture of skin and say, what does this patient's skin problem is, the computer can't answer it. So that would be for me.
Well, I would call the work a particular breakthrough, but it was an interesting project. So some of my work is in an area called representation learning. They just want to take some of these difficult to answer semantic problems and sort of project them into a vector space, so that you can take these semantic questions, essentially render them as geometric questions. For those who might be familiar with Word2Vec, it's techniques in that particular domain. Where if you take, like, say, the vector mapping for king, subtract the vector mapping for man, and add the vector mapping for woman, you actually get a vector that is approximately the vector for queen, right? So you take this semantic problem, you make it a geometric problem, and that technique of embeddings and representation learning, has been shown to be useful in a few cases. So a problem that I worked on, this is about 3 years ago, was representation learning for sign networks. So sign networks are these like social networks where you have antagonistic and friendly relationships coexisting within the graph. So imagine a Facebook where you can not just friend somebody, but you can enemy someone as well. There are actual social networks that actually do have such a mechanism, or this mechanism is actually implicitly there. For example, in Bitcoin exchanges, you actually have a distrust mechanism in those social networks. So the problem was applying representation learning to those sort of networks, and being able to do things such as predict if two users would trust or distrust each other, as well as being able to actually find these competing coalitions within the graph. It's like one visualization that was a bit that was actually quite a nice indication that what we're doing made sense, was that we took the voting records of the 104th US Senate, and we were actually able to project the senators into a space just using the information of who voted similarly to whom, to separate out the Republicans and Democrats quite clearly within that vector space. So I mean, to me, it's the paper that I've worked on that I'm the most proud of. It's also the one with most citations. So that was, I would say, the biggest quote. I wouldn't call it a breakthrough, but that's close and quote was breakthrough I've worked on.
Okay, well, yeah, in my case, I work with several different students on different things. One thing I've been interested in recently, and again, it came about because our environment is different. It's a small island, small data sets, So if you look at an insurance company, you have very few customers compared to an insurance company in the US, right? So if we were looking at personalized insurance, if Emily came to us, can we predict her risk with reasonably good accuracy? And of course, the more data you have, if we have millions of samples and we have hundreds of people similar to Emily, yeah, we could come up with a good estimate of risk. But if you don't have that many samples, we can't. So we cannot say, well, this is the error range would be too large. So the question is, how do you make this trade-off? Should we say, all right, we could get something precisely for Emily, or do we say, well, we could get something, we could get a prediction, but it would be for somebody like Emily between the ages of plus or minus her age, etc. So it won't be as personalized, but we would be more comfortable in that prediction. And so we have to do that trade-off because of our smaller sample size. So that's one thing I've been looking at, that trade-off, finding the optimal trade-off between the two things, personalization and robustness of the estimate. And yeah, some other things I've been looking at, but that was of interest because insurance companies have that issue.
Just an aside, I guess it's more for the last question. There was an example of something that I would say is evolutionary in coding. I forgot that was on the tip of my tongue, but I couldn't remember the term. Object permanence is actually something that it turns out has, it's something we might be born. We're not necessarily born with. We're born a predisposition towards object permanence. So object permanence is knowing that an object exists even when you can't see it. So babies actually pick up on this faster than they actually would otherwise if it wasn't something we have an innate tendency towards. So as a bit of an aside, it's just the example that you tip my tongue. I just couldn't remember the time.
I thank you all for your answers. For this segment, we're just going to be asking each of you one question individually. So we're starting off with Professor Juerg. If you are a student beginning your AI journey today, how would that differ from your actual start? And also, what developments or opportunities today would impact your journey?
I think some elements would stay the same. I spent extracurricular activities in getting good skills in presentation skills. And the funny part was that at ETH, you had to go to the military side of the school to get presentation skills because the academic side didn't teach it. The other part, which I would do more, is really understand more of the industry, the financial world, how the economy works. I learned that much later in life when I was already a manager in IBM, and I had to start worrying about, not just the mathematical things of stuff, but also about why and does this make sense. I would spend more time on getting my general knowledge earlier than I did. What I wouldn't change, I did read a lot. I did read a lot of science fiction. And if you plot a lot of science fiction, they're actually fairly good at predicting where things might go. And so that might be a good thing to just hone your thinking and bigger picture and projecting stuff. And where could this go to? What could be happening in the world, right? If you think about current electric vehicles, what will happen to the car mechanics? Because you're going to need a lot less of those, and so on and so forth. What are the implications of some of these things? So I would spend more time in not just enjoying science fiction, but actually start to think a lot more about logic and projections and how to think about the big picture.
Nice. I honestly like that. I think I should read more science fiction as well. Hey, Mr. Inzamam, what topics in AI have proven most relevant in your line of work in the local context? Why and what are the limitations?
Okay, so I suppose the one that's most obvious when I was just thinking about it would be machine learning specifically. We work with a lot of classification problems. Now, of course, I can't go into too many details because of NDAs and such, but a lot of it tends to take the form, not say of just even using just the classifier's output, 1 or 0, but using it to assess the probability of different outcomes, and being able to meld that with certain stakeholder requirements to be able to build decision support systems that way. So a lot of it has been in that space of classification and supervised learning. We've had some work. We've done some work in the unsupervised space as well. But it's because it turns out that using these outputs, these probability outputs, and these tend to be useful when you want to take that and then transform that into a form that somebody can use in a decision support system. In terms of limitations, of techniques, of course, the real world data is really messy, and you tend to have a lot of missing data. And I mean, that's true across the board. You'd never have these nice, you go in Kaggle and see all these, these nice pristine data sets. The real world's not like that, not at all. And I think in particular in the Caribbean, because that's even more so. So, sometimes you have to find workarounds with those sort of data quality issues. That can actually be a bit of a challenge / limitation. Sometimes you do have to make, from the particular context, assumptions to try to actually deal with that. As George Box said, all models are wrong, but some models are useful. And data, that adage there is sort of something you kind of have to use as something to live by when you're in industry. You're gonna have to accept that that your models are always going to be somewhat incorrect in some way, and still find ways, try to make them useful. And interesting enough, this also kind of plays with Jeff Altman. I know I would have mentioned him, right? I suggest everyone who's interested in data science to actually watch a talk he gave at the University of Waterloo back in 2018 called "Does Data Science Exist?" He sort of distinguishes between statistics and data science, saying that statistics is about analyzing data, but data science orients itself towards problem solving with data. And that's something, I guess, a bit of career advice there, but just kind of to keep that distinction in mind, right? That and because that helps you try to find ways to actually overcome and surmount some of those limitations you have because of things like data quality issues and the like, and still deliver something that to a business stakeholder is still useful and worthwhile.
Thank you for your very enthusiastic answer. Next, we'll move on to Professor Hosein. You mentioned the challenge of limited data sets. So in your view, does that pose the greatest challenge to AI research and innovation in the Caribbean? And if not, what is and how can it be addressed?
Well, it is a big challenge. Not only the availability, but the quality of the data collected. So, many companies collect data, but since they don't use it, they don't really verify, the quality. They don't check to see if, the fields were filled out, etc. As Inzamam pointed out, there are lots of missing data. And one issue we tend to have is when we go into to work with a company, the owners of the data are sometimes reluctant to share it with us because of that, because they know it isn't as the quality isn't as good as it should be. So that's one thing, the data quality, the quantity I mentioned before, and also the sharing. People, for instance, we several years ago, 5-6 years ago, we set up an open data platform, data.tt, with the hope that people would share data and we would be able to use that to do research and come up with solutions to societal problems, etc. And one ministry shared data. None of the government agencies wanted to share. Even research organizations didn't want to share, etc. So that's another issue. Even if the data is there, sharing it. So that tends to be our biggest problem when we try to come up with a project, identify a data set. Now we could use public data sets, um, but those were created for in a different country. So it doesn't really um, has the unique features that we would want for in our case. Also, those public data sets, sometimes the quality is not great either, but and also they are overkill, meaning that people, hundreds of students have used them already. Um, so we try to avoid, we try to use local data sets. And that's why we ended up doing this internship program, because it allows us to go into a company and identify a problem that the company wants solved, and in that way the company works closely with us, of course with an NDA, to solve that problem. And in most cases there's more cooperation, because the fact that we're doing something for them, um, and we do it in such a way that the people, the data owners, the database managers, etc., are involved in the whole process. And in fact, they typically are authors on whatever publication we do on that project. So it's getting them involved and showing them, look, we're not after you, we're not trying to replace you, replace your job or anything. We just want to help you do a better job. And and in terms of how do we address that? Well, we have to just work with companies, with the government, show them how to collect better data, and show them the advantages, the benefits of sharing that data. And of course, you have to anonymize, etc., aggregate. But there is so much we could do if we had the data.
All right, thank you for your answer, Professor Hosein. I believe that that's all the questions that we have for the panel. So right now we'll be moving on to the event announcement, which would be a small robotics coding camp. The software and system that we're going to be using is the Lego Mindstorms 51515. I'm not sure if you guys can see them properly. But yeah, so I'm gonna show a small intro video so you guys can see what exactly the set is like. So that's gonna be first up. Let me just share my screen.
Hi, Emily.
Yeah.
Okay, so maybe before we get that, maybe we could just give a vote of thanks for our speakers.
Oh yes, my
Thank
bad.
you all so much. Thank you all so much for coming out. We're so happy to have such distinguished panelists, and I think it was a lot of really informative for these students. It's so it was so much information that we got, and we're really grateful for you all to coming out. So thanks again to our speakers, and maybe we could have more events.
Thank you for having me and us, and I wish all the students all the best for their future.
Excellent.
Yeah. Thanks for.
Yeah, go ahead, Inzamam.
So thanks for having us, and it's good that you all would like to have these sort of like conversations, because it shows you're in the right mindset towards being the sort of thought leaders, for lack of a better way of putting it, that the Caribbean needs, right? If you're to stay competitive with the rest of the world, and to solve the incoming major challenges, particularly of a post-COVID world.
Yeah. So thanks for having us. And it was a pleasure talking about these issues. I also want to mention that we do have a monthly seminar, and all of you are invited to attend. I believe Jeremiah has the information. He has attended in the past. And what we do is we present any publication we had in the previous month. So this Monday past, we had 3 presentations. In December, I think we have probably, 7 presentations because we have 7 papers coming up. So feel free to join. Don't think it will be this highly theoretical stuff. Some of it will be, but a lot of it is real world problems, and you will see how we apply some of these tools to those problems. So thanks again. I won't be able to stick around because I have a flight coming up, but yeah, thanks again for the opportunity.
Awesome. You're all very welcome. Thanks again for coming.
Thank you for coming out. We have one question from Nicholas Smith in the audience. Can I ask for one book recommendation from the speakers for someone who is now starting in machine learning AI? Thank you.
Sorry, off the top of my head, I don't have one.
That's a really, really tough question, because each of the different books have the different strengths and weaknesses, and actually there are some books that I'd go to for some to review some topic or to learn about some topic, and and not use for others. But if it's for machine learning specifically, there's machine learning a probabilistic perspective. That is probably, it's just for machine learning specifically, and to get started there, that would be the book I'd recommend as the one book. But of course, you're going to need a lot more to there are skills you have to build around that machine learning. Something, I guess, a bit of a side, I would also recommend. I would recommend also reading about some operations research. It's not something that tends to be discussed much within UE, but a bit of an aside, I would recommend learning about some OR, I guess, in that regard as well, because that OR teaches you a lot about how to actually suss out and formalize problems, particularly from business economic contexts. And for that, the book I'd recommend is Introduction to Operations Research by Hilber and Lieberman. But for ML, the machine learning probabilistic perspective is a really nice good book. It takes you all the way from understanding probability, assumes no real background, and it takes you all the way up into into deep neural networks and understanding about projections onto manifolds and the like.
Yeah, in terms of books, yeah, I can't. What I would normally recommend students, if they want to start off in this, is online courses, and the one I recommend is the one by Andrew Ng. It's called Introduction to Machine Learning, I believe, or something along those lines. It's a Coursera course from Stanford. So it gives you a kind of simple, an easy introduction into machine learning, and it's hands-on. So you have to actually do programming. Well, he uses MATLAB, but you have to actually do programming, and that's how you actually start to appreciate the power of some of these tools. So I would say, yeah, take that online course. There are several of them, of course.
Great, thank you. I will hand everyone back over to Emily.
All right. Okay, so I'm going to share my screen and I'm going to show the video. So give me a moment. All right. You guys can hear it, right?
With the new LEGO Mindstorms Inventor, kids and adults can create and code one of the set's 5 personality-packed robots, or build and bring to life anything they can imagine. With easy-to-follow digital building instructions and intuitive drag-and-drop based coding, kids can learn the basics of coding, expand their programming skills, and experiment with funny, creative robot designs. The LEGO Mindstorms Robot Inventor app is packed with over 50 fun activities to challenge coders of all abilities. With the app, you can also create customized remote control experiences for the models or code your own third-party Bluetooth controllers. The 5 models in the set are Blast, a master robot and the action hero of the set that can shoot, punch, grab, or hammer its way through obstacles. Tricky, a sporty...
All right, so we're stopping it here because the other robots wouldn't be the one that we would be working with for the coding competition. So this is, well, a model of Blast, and he's the one with the turret attachment. And how it works is that they have different motors. So at the bottom here, there's 2 large motors to control the wheels for movement. There is the turret with another motor attached to, there's the triggers on the back. So there is a piece that will move like this so that it will trigger the left or the right turret. This is the brain, which also has an LED matrix. I'm not sure if it will be able to show on screen, but we'll see. And then in the back here, we have a larger motor which controls both of the arms. And on this arm, we have this light here is actually a color sensor. And then on the bottom, we have an ultrasonic sensor. And why we wanted to use this kit for the coding competition in particular is because it has the ability to use Scratch, which is a programming language, a word block programming language that was made by, I believe, MIT students, which is, an easier approach to coding for someone who doesn't know things like Python. And for most people here, you would know that Python is one of the coding languages that people use for machine learning, which is also a part of artificial intelligence. And one of the reasons why we wanted to use this set also is because there are local opportunities for robotics events with using this kit. And it's run through both Nehurst and Shell. They are the local liaisons for this competition. This was one of the sets from the hydrodynamics season, and then the other one was Into Orbit. I don't think they ran another one last year because of the pandemic situation, but when the new season starts, normally they get announced in August. That is when you can go on Nehurst and see everything else that's going on if you would like to sign up for it. So now we have a small demonstration about how to use the app. I believe you guys should be able to see the screen. So in the middle here, we have the robot that we'd be working with. And if you click on him, you get some of the videos, and they'll show how the movements work. And just for you to get an idea of the parts of the robot and how they move. But the part that we would be using is the coding section. And when you first open it, it's going to open on the page with Scratch. And the handbook at the side here, the word blocks, these give you more insight into how to code and what to code using the word blocks. And for those of you who would like to use Python, you go up here, open a new project, and create a Python project, which also has a handbook at the side to help with different functions as well. So how we wanted to run the competition is that you have a week to write your code. I believe that the download to the app is in the UX Discord server, the GSDC Discord server, and both of the group chats as well. And since, not everyone would have the system, what we wanted to do is that you guys would save your files and send them to the email. I hope somebody could put that in the chat real quick. And the deadline is Sunday, the 14th of November. And after that, after we've received your code, I'm going to run it on the robot, and we will be sending you guys videos of the output. And yes, I believe that's everything. Michaela, you want to come back?
Sure. So I sent the link to the app in the chat, and Zane also sent the email in the chat. So if you guys are interested in taking part, you can install the app and email your code, as Emily said. Are there any questions from the audience with respect to this or anything that was discussed today?
Okay, I don't think we have any questions from the chat.
Yes, rate today's
Thank you
session
for
out of
being
10.
here.
Wait, before they leave, rate today's session out of 10, everyone.
Oh no, wasn't somebody in the chat said it was a good session, so I was telling them thank you for being here.
Nice. Not currently, but this was a great way for me to dip my toes in and learn a bit more about AI. Yes! Thank you for coming, Faith. 11. I agree.
10 out of 10.
Yes, if there's nothing else, I believe we can end now. I would like to once again thank our panelists for coming out. Thank you, everyone, for tuning in. Thank you for the questions. And enjoy your night. Anything else, Emily?
Nope, that's all.
Anything, Mr. Mendez?
Congratulations to GDSC leads on your first successful event, and I hope to see many more. I think it went very well. It's awesome you got these panelists together.
Thank you.
Thanks for everyone to coming out. Thanks for all the.
And I'd just like to say a special thanks to Emily and McKellar for making this event successful, and all our the rest of our team for helping out and making today happen. So thank you very much.
You're welcome.
All right,
Thanks.
well, that's the end. Thank you all for being here.